You know, you've probably seen those videos of massive automated factories, everything moving in perfect sync. It's like this incredibly complex robotic dance. But it begs the question, right? How do you choreograph that whole dance before you even build the stage?
I mean, really think about that. You can't just drop millions of dollars on a facility, flip a giant switch, and just hope for the best. The cost of getting something wrong is, well, astronomical. So how in the world do you kick the tires on something that doesn't even exist yet?
Well, here's the secret. You don't build it in the real world, not at first. You build a perfect digital copy, a simulation. It's a virtual world where you can run thousands of tests, find every single flaw, and perfect every little movement, all before a single piece of real-world hardware is even ordered.
So, let's do that. Let's step inside one of these digital factories. We're going to take a look at a simulation of a core process you'd find in pretty much any modern warehouse, the automated logistics loop. Okay, so what we're looking at here is a 3D model of an AGV track system. An AGV just stands for Automated Guided Vehicle. Honestly, you should just think of them as the robotic workhorses of any modern warehouse. They're the ones zooming around, delivering parts with just, perfect precision. Now, to really get what's going on, we need to meet the team. I know it might look kind of complex, but it's really all built from just a few key components, all working together in perfect harmony.
All right, so let's build this thing out in our minds. The star of the show, of course, is the AGV, our little transporter. It needs a road to drive on, and that's the AGV track. Its whole journey starts at the loading station, where those big robotic arms are doing all the heavy lifting. And its destination? Those 2 delivery stations, where it's going to drop off its cargo.
Okay, so now that we know all the players, let's actually follow the action. We're going to track one of these AGVs as it completes a full delivery loop, and we'll do it step by step.
It all happens in 4 pretty simple steps. First up, loading. The AGV pulls into the station, and a robotic arm loads it up with 4 parts. Next, traveling. It takes off down the track to the first delivery point. Then, unloading. Here, robots grab 2 of the parts, and then it continues on to the second station to drop off the final 2. And last, the loop back. Once it's empty, it just zips right back to the start to do the whole thing all over again. It's just this non-stop, perfectly synchronized dance. So, this whole thing looks incredibly smooth, right? But what's actually conducting this orchestra? I mean, there are no human drivers here. How does the AGV know exactly when to stop or when to tell the robots to get to work? The answer is sensors. They are the invisible brain of this entire operation. They're placed at key points all along the track, and they basically act like digital tripwires. As an AGV passes over one, it triggers a pre-programmed command. Stop here. Activate that robot. Wait for 3.5 seconds. The sensors are the conductors, making sure every musician plays exactly on cue. Now, this is all really cool to watch, but let's be real. Engineers don't build these just for fun. The entire point of running a simulation like this is to get one thing: hard data. And that really gets to the core mission here. It's simple: to see how the system is performing. Before you spend millions, you have to have answers. Is it fast enough? Is it efficient? And crucially, where are the hidden bottlenecks that could grind the entire line to a halt? And that brings us to the single most important number you can get from this: throughput. This is the ultimate metric. It answers the big question: how many parts can this system process in 1 hour? And for this simulation, the answer is just under 109. And this right here, this is why simulation is so incredibly valuable. You can get super granular data for each part of the system. So delivery station 1 is hitting that 108.97 jobs per hour. But look, station 2 is just a little bit behind at 107.69. Now that difference might seem tiny, but in a real-world factory, that's a clue. It could reveal a potential bottleneck or an area you could optimize to make the whole system faster.
So here's the bottom line. Simulations are basically a crystal ball for engineers. They give you a safe digital world to find and fix problems, saving just incredible amounts of time and money. It's all about making your mistakes cheaply on a computer, not expensively on the factory floor. And that kind of leaves us with one final thought. This same logic, building a digital twin to test and improve a system, you can apply it almost anywhere. From managing traffic flow in the city to optimizing the checkout lines at your grocery store. So what process in your world would you want to simulate just to find its hidden potential?